My dear students, in this class we will consider two examination problems. One problem it comprises of prismatic board as well as tapering board. Another problem only prismatic board or stepped board you can say. So here in this first problem, what he has given is this is a composite bar which consists of three segments. One first segment is prismatic, that is diameter is same 40 mm diameter. Second segment is tapering, diameter varies from 40 mm to D is unknown here. Third is prismatic once again, whose diameter is uniform throughout, that is D. This entire system, entire bar is subjected to a tensile force of 150 kN. So P value is 150 kN here, or 150 to 10 power 3 Newton. He has given that this material is made of steel whose Young's modulus is 200 GPa ES value. We have to convert that into MPa or Newton per mm square, which is 200 into 10 power 3. Then in this problem he has given total elongation as 2.4 mm. So total elongation means since all the three segments are subjected to tension force 150 kN same, all the three segments will be elongated. So delta L1 is positive, delta L2 is positive, delta L3 is also positive. So here the entire sum delta L1 plus delta L2 plus delta L3 is delta L, which is given as 2.4 mm. Then what he has asked is what should be the diameter of this last portion D. So in this problem diameter is unknown, he has given the elongations, total elongation he has given. So what we have to do here is we have to consider them separately, because this is prismatic portion, this is tapering portion, this is prismatic portion. We have to consider them separately and we have to apply the formula separately. So first I will consider the first portion, prismatic portion or prismatic bar portion 1. So we know that for the elongation of a prismatic bar, the formula is PL by AE, PL by AE. So here this P is same. In the last problem we have taken P different values, but here P remains same, 150 kN tension force. So L is L1. L1 here is 1 meter. So length of the first portion is 1 meter. I will take it as 1000 mm. Then divided by A1 into E. So area we have to calculate. He has given the diameter here. If he gives the diameter of the specimen or the bar, the area is given by pi d square by 4. You know that. So now if you substitute the values, P is here, P and E they are constant here. For all the three portions, P is same and E is also same. That's why what I have done here is I have taken P by E outside. It's common for all the three. Into L1 by A1 it becomes. So L1 is 1000 mm. Please see that this is in millimeters. Meter is converted to millimeter, and area of the first portion is pi d square by 4, where D is 40 mm. So D you have to substitute here. You are going to get some value here. Of course, into P by E will be there. So P by E into some value you are going to get. That you have to calculate. So this value. Put D as 40. Pi d square by 4. Then for the second portion, the formula is different because it is tapering bar. We know that the deformation of a tapering bar delta L is 4PL by pi e d1 d2. So 4PL. So here L is L2 here, which is 0.5 meter, 500 mm. So here also I have taken P by E outside, common. Then what remains? Whatever remains. So 4 into L2 is 500 mm. So this is also in millimeters. Please note. Divided by pi into E I have taken outside, d1 d2. Here d1 is 40. Please note that d1 is 40 mm. It is varying from 40 to d. So d2 is d. So you are going to get another value here after simplification. Of course, in this, in the denominator you will be having d. Please note that d will be there. It is unknown. P and E we can substitute at the end. So this is the formula for tapering rod. Next, the third portion is once again prismatic. Prismatic means it is PL by AE. So delta L3 is PL3 by A3E. So here P remains once again same, AE is constant, P by E I have taken outside, L3 becomes 500 mm. So third portion has a length of 0.5 meter. So convert it into millimeter, 500 mm. And of course divided by area of this will be pi d square by 4. Here D is unknown. So here what we are going to get here is P by E you can take outside into some constant value divided by D square you are going to get. See, divided by D square term will be there. So here you please note that here there is no unknown term because some constant value are given. Here divided by d will be there because d is unknown. Here divided by d square will be there. Now he has given that the total elongation delta L is delta L1 plus delta L2 plus delta L3. All are positive because all the three portions are subjected to tensile force only. So we have to add. So delta L is 2.4 mm given in the problem. Therefore, what we have to do here is we have to substitute for all these values. So delta L is equal to now 2.4 mm, which is sum of all these three. So delta L1 is this. See, this is delta L1. P by E into some value are going to get, plus delta L2 is this value, P by E into some value divided by D, plus delta L3 is P by E into some value divided by D square. So once you substitute these here, so delta L1 is this, plus delta L2 is this, plus delta L3 is this, is equal to 2.4. So RHS becomes 2.4, and for P and E also you have to substitute. P is 150 into 10 power 3, E is 200 into 10 power 3. So you have to convert to Newton and millimeters, and once you substitute and simplify, you will get a quadratic equation in D. You will get a quadratic equation in D. So you have to solve that quadratic equation. You will get two values for D. One value you may get negative, another value you may get positive. So what you have to do is you have to take the positive value. So among the two values, which value you have to consider, that you can judge after getting the solution. So you will be getting two values of D, out of which the one value is 19.9 mm. So if the diameter of this prismatic portion is 19.9 mm, then the elongation, total elongation will be 2.4 mm. So this is another type of problem wherein total elongation will be given and you are asked to find the diameter or area, whatever unknown, or length also can be unknown. So they may give here this length, they may give unknown, diameter they may give. Then in that case L3 will be unknown. So one unknown can be easily solved. So length can be unknown, diameter can be unknown, area can be unknown. So once you substitute in the equation and simplify, you are going to get the answer here. So this is D 19.9 mm. So that is the answer for this problem. Okay, now we will have one more problem in the same question paper. It is a very simple problem. So he has given a stepped bar here. You can observe here, this is like a column, stepped footing. Footing you can say. In this small footing here, this bottom portion is circular in shape, so which is 25 mm diameter. This bottom portion is like this, circular in shape. So the diameter of this is 25 mm. This is the plan. So in plan, you can see like this. Okay, this is the cross-sectional area. Cross-sectional area. So this is A2. Because it is second portion I have considered. This is A2. A1 will be like this. This diameter is 12 mm. This is 12 mm. And this is A1. Okay. So what he has given here is, there are two portions here. Actually this is a column. It is a vertical member and compressive force is applied here. This 12 kN is a compressive force. It is acting on this stepped column or footing you can say. Here what he has asked is, what is the value of maximum and minimum stress that is produced in the stepped bar. So what is the value of maximum stress? What is the value of minimum stress? That's all. So if you observe the problem, both these portions are subjected to same force, 12 kN. Both the portions, both the segments 1 and 2, they are subjected to same compressive force C, but the areas are different. If you observe the areas, this area is less. Area of A1, first portion is less, area of second portion is more. So you know that stress is inversely proportional to area. If this force acting is same, then stress increases with decreasing area. So naturally, because it comes under the denominator, area comes in denominator, sigma is equal to P by A. P is the force acting on that particular member and A is the cross-sectional area of the member. If area is less, the stress will be more. So very simple concept. So here he has given P as 12 kN compression, that kilonewton will convert into Newton, then calculate A1 and A2. So this is circular in shape. Suppose if they give rectangular in shape, we have to take width and width in both the directions, you have to multiply. It is circular in shape, therefore areas are given by pi d square by 4. So A1 is pi d1 square by 4. D1 is this 12 mm. D2 is this. So find out the areas A1 and A2 and you get some values in millimeter square. Then, as I already told, stress is more if the area is less. So area is less for the first portion, therefore maximum stress occurs in segment 1 whose area is less. So area is given, the stress is given by sigma max, that is maximum stress. Sigma represents stress. So maximum stress is given by P by A1 here because A1 is less. P is 12 into 10 power 3, A1 is this value. Substitute and simplify, you will get the stress value in Newton per mm square. Similarly, minimum stress will be in the bottom segment where area is more. So here diameter is 25 mm. Pi d2 square by 4 I have taken. So same, P remains same. So 12 into 10 power 3 divided by A2. It is the minimum stress. Minimum stress occurs in segment 2 since its area is more. But both are compressive stresses only. Both the stresses are compressive stresses because the same compressive force is acting on both the segments. This is a very simple problem. But why he has given this for 4 marks is, so you should know the concept of stress, how stress varies. So stress is directly proportional to force, inversely proportional to area. So where area is less, stress will be more. Where area is more, stress will be less. That is the concept he has given this problem. Thank you.